Let's continue, my friends, now. The next presentation, the last presentation, will be about user software. So we take example Maglumi 800. We will see the home page of the user software. Then we will see the interfaces, 4 interfaces: process interface, system interface, definitions, and results. So let's start by the home page. In the home page, on the middle, you can see we have the logo of the Snipe, the model of the analyzer, and the version. We have the mode, random mode or normal mode, and the time and the date. And here we have the remaining time for the experiment. It can be calibration, it can be sample test, and it can be also maintenance. We have the countdown for the current experiment. And on the bottom, then we have the sample. Here we have the sample and reagent area. So it displays all the slots on the sample area and the reagent area with different colors, depending on the status of the sample rack and the reagent kit. On the bottom, on the left side, we have the error log. So here are displayed the error message in real time. And in the bottom, we have the connection status. So the status of the connection indicator, COM1 and PLC for the communication. If they are green, then means the software and the analyzer are connected together correctly, and the computer also, and everything is okay. We can start using the analyzer. If the color is red, then that means the connection is not established. We have another status indicator for the experiment status. That means when we run the test, this one is when the analyzer is running tests. This indicator will be should be green. When there is no tests ongoing, this one will be red. Here we have the pause measure. So if we click here, the measure will be stopped, will be in pause, which means this can be used in case of emergency. For example, you see that there is leakage on the analyzer. For example, you see that you forgot to remove the cap from the tube. Then the needle will crash on the cap. So you can use this one to take the action quickly and then click again to continue testing. Here you can see the consumable status, but also the temperature and the humidity and voltage. And here you can lock the software. If you click, if you click this one, then it will display you the interface for the login, the user and the password. If you click it, then to enter again, you need to enter the password. And this one is to log out, to quit the user software. On the top, we have the Maglumi model of analyzer here. And here we have the different interfaces, button for the interfaces. We have the start button to start the experiment, system test to choose you remember the repetition for the priming, BGW, and live check tests. And then we have the sample and the reagent interface to see the status of the sample and reagent area and to order the samples to start launching the tests. And in this presentation, we will see these 4 interfaces in detail: process, definition, system, and results. So firstly, when you log into the user software, the first thing and turning off on the analyzer, the first thing to see is the indicator, and then the status of the sample and reagent area. For the sample rack status, we said that we have green color and red color. Of course, we have the gray color. Gray means that it's empty. So the green color means the recognition is successful, and the red color means the recognition is failed, and we need to take out the rack and load it again to scan again. For the reagent, also we have different color with different meanings. So the gray is empty position. The other colors, the green means that there is a valid calibration and the kit is ready to use to run the tests. The red color means the recognition failed and you need to remove the kit and scan it again. The black color means the reagent kit expired, so you need replacement. The purple color means the working curve is expired. We need to recalibrate the reagent kit. And the yellow means the reagent kit is new and it doesn't have the working curve, never calibrated before, so you need to calibrate it. The gray is empty reagent position. And we have seen that inside the sample and the reagent interface, we can have also the display of reagent with two squares in the bottom of the kit. The two squares has different colors. So the two cases where the calibration is needed is when we have the purple on the left side and the gray on the right side, or the red in the left side and the gray in the right side. Then the calibration is needed. And I told you, you have to check the indicator of connection. After turning on the analyzer and computer, the COM and PLC status should be green, both of them. If the COM port is green, if the COM indicator is green, then the meaning is that the computer has the ability to connect with the instrument, with the communication cable. But if it's red, then we need to now communication and now ability to connect. So we need to take the actions, maybe change the communication port sitting in the service software. Maybe in the computer, it is connected to the COM2, for example, COM2. And this is the analyzer. This is Maglumi. And this is the computer. And if it's connected in the communication COM port 2, you need to check that in the service software, in the computer, in the service software, it is also COM2. So if it's COM1, then it will not connect correctly. So change the communication port in the service software according to the communication port selected physically in the computer. Reconnect or change the communication port. Check whether the communication port is damaged. The interface itself of the communication port in the computer is damaged, or maybe the cable. Contact Snipe Engineer. Then for the PLC, the meaning for the green color is that the computer has been connected successfully with the instrument. If it's red, then it means it is not connected. Then we reconnect or replace the cable, RS232 cable. Check the indicator light on the COP board. Contact the engineer. For the experiment at the right side, if it is green, that means there is tests running at this moment. If it's red, that means there is no ongoing test. Then for the home page, also for the pause measure, when we use it. When we click pause measure, all the component will stop. After that, after you take the necessary action, click continue to continue the experiment. When we use it, when we load the sample urgently, so some emergent sample, something falls in the analyzer cover, which will cause needle crash. Then we have the system liquid status and system liquid and starters. for the status of the system liquid and starter consumable status. If the amount of the system liquid is higher or starters is higher than 20%, the color displayed is green. If the amount is less than 20% for starters or for system liquid, it will be displayed in yellow color. But after that, when the status of the system liquid or starters stay in yellow color for more than 30 minutes without replacement, without any actions, the instrument will stop and warm, and the color will turn to red color. Then for the waste status, so for the waste status, it is about the reaction cuvette. Let's see the different color. We have the red, the yellow, the green. The red color is when the waste container, or the cuvette dustbin contain more than 80%. It will display red color for the reaction cuvette. When the amount of the cuvette discarded in the cuvette dustbin is between 60 and 80, it will display in yellow. And when the amount is less than 60, it will display in green. So remember, we are talking about Maglumi A100. So it is different with the other Maglumi for 2000, for example, or 4000. So this is just an example. And for liquid, waste liquid, it is red when it is the level of the liquid in the waste tank is between 90% and 100%. Yellow between 80 and 90%. Less than 80%, it is green. What you need to know is that there is special case for the reaction module waste. In case you empty the dustbin, the cuvette dustbin, you need to click reset in the software in order to turn it again to the green color and to reset the counter to 0. Because if you don't do it, it will stay in red color. So when you empty it physically, you need to click reset to reset the counting. Then we will see the interface process. In the interface process, we have many other functions. Firstly, we have the warning options. The warning options is some error message that the end user can disable. So when you disable, this error message will not be displayed, but it is not recommended to do that, except for the cover of the analyzer. If the analyzer alarms that the cover it is open, even if it is closed, maybe the sensor has a problem, maybe the cover is not well installed. So you can disable this one, no problem. But for the others, don't do this. Imagine that the customer disable, for example, starter 1 is almost empty, please replace, for example. Then, for example, there is low level of starter 1. The customer disable it because he know that he just have 1 or 2 tests to run, and it's enough to run 1 or 2 tests. So it disabled this starter
Recording
1.
in progress.
It disabled this alarm message, and then he think that after he finish 1 test or 2 tests, he will replace the starter 1. He will add, but only he will do it after he finish the test. But after that, he forget to replace the starter 1 bottle after finishing his test. He forget to replace it. So next day or next time, he will still continue running the sample, but the starter bottle 1 is completely empty. And because he disabled the message, so he will not get the alarm message. And then he will call you and tell you that I don't have the results, for example, or maybe all the results are negative, are very low. And when you ask him, what is the error message? he will tell you that everything is okay. The analyzer is perfect, no problem. Just I don't have the results. I can't understand this. So if he say you that he has problem with the results, but no alarm message, you have to think for this interface directly that something is disabled, some alarms are disabled in the warning options in the process. So pay attention. Next is the initial with clear. The initial with clear means the initialization of the instrument with clear cuvette. The initialization with clear cuvette means if there is cuvette in the incubator or in the washer or in the back transport or in the chamber, the cuvette will be discarded during initialization. The analyzer will check for this cuvette and discard them because they are used. So first initialization and then clear the cuvette. It will initialize and then clear all the cuvette left in the each component. When to use this, the instrument shuts down accidentally during the test. Maybe the power is cut, the power supply is cut. So it is stopping, the analyzer will stop during testing, which means that there is cuvette that are in different component. So these cuvette are lost. We need to discard them. So the analyzer, the order is like this. The analyzer will remove firstly the cuvette from the chamber, then from the pusher between the chamber and the washer, then from the washer, then from the incubator, then from the back transport in this direction. So points that determine the time of initialization with clear cuvette. So what determines the time, the duration of the initialization with clear cuvette? It depends on the slot of the incubator. For example, Maglumi 800 has 30 slot. Maglumi, the others had 2000 has 16 slot. So it depends on the number of the slot on the incubator. If we have more slots than the initialization and with clear cuvette, will take more time. The number of remaining cuvette in the analyzer, maybe we have only one cuvette remaining in the chamber. Maybe we have cuvette in the chamber, in the washer, in the incubator, in the back transport, and so on. Depends on the number of cuvette remaining on the analyzer. This is the initialization with clear cuvette. Then we have the other function is restart in the process. We have restart. So restart is to return those tests have not released the results because of sudden shutdown of the instrument during testing. So when to use restart, the instrument shut down accidentally during tests while the user software is not logged out. So the user software, the computer is still on and the user software is still connected. In this situation, after we turn on again the instrument, it will initialize automatically. Then we need to initialize with clear cuvette, you remember? In order to remove any cuvette remaining inside because the analyzer shut down accidentally. After that, we click restart. So those results show active, can be restarted automatically. So some of the tests maybe are finished and display the results. Some tests are not finished. So we don't need to go to the sample and reagent interface and order the samples from zero. For the samples that shows active, they are ordered. So the memory existing, so they are saved and they are still ordered. The analyzer recognizes this order, so we can restart these samples without making order from zero. If one cuvette, but in this situation, you need to make sure when you before you turn on the analyzer, if there is one cuvette in the incubator and one cuvette in the pipetting position. So this is the incubator. This is the pipetting position on the right side of the incubator. you need to make sure if there is one keyvet here and one keyvet here, there will be a crash between the two keyvet. In this situation, you need to remove this keyvet manually before turning on the analyzer and using initial with clear keyvet. So this need to be removed manually. Then we have return assay, another function in the process interface, return assay. So the analyzer will automatically deduct the remaining tests of the reagent kit after clicking start. So what is the meaning? If, for example, we have a reagent kit with 90 tests remaining, so you know the analyzer is displaying the remaining amount of tests in each kit. So if, for example, I have 95 reagent parameter for TSH, remaining 95. When I run the tests, just when I click start, this test will be removed from the remaining number of tests. It will display directly 94 instead of 95, even if the reagent is not pipetted yet. So just after we click start, the number of tests will decrease. So in this situation, if the analyzer turn off suddenly, shut down suddenly, and the pipetter doesn't pipette the reagent, so I can restore the counting for the remaining test for the reagent kit. So how to do that? Because these tests are not consumed. It is just, they are just removed from the total amount of tests after I click start. So when to use this is the instrument shut down accidentally during the test while the user software isn't logged out. So how to use it? Turn on the instrument again, click initial with clear keyvet, we said, and then click return assay. Those tests haven't been started pipetting can be returned. And after clicking return assay, the remaining tests will be restored. So if it was 95, it will be, after I click start, it will be 94. And then if the analyzer turn off before the reagent is pipetted, I can use the return assay and the number 95 will be restored again. Then the other interface is definition. So for definition, most of the settings are in this interface. Firstly, we have on the left side some functional button. We have tests, control, group, profile, diluter, result definition. So for the test, it is to check and edit the specific assay information. All the assay information are displayed here. Just select the parameter and check. And for the control, check, add, modify the quality controls information. For the group, make the assay can detect quickly, can be selected quickly when set the test. So make a group of tests that will be displayed in the sample and reagent in the first page. So quickly we can select them. Then the profile is also a group of tests that will be displayed in the sample and reagent interface and can be selected as a group by only one click. Diluter allows the user to set self-definition dilution. And the results definition is specific definition for results that the customer can choose or not. Firstly, for the interface tests, click definition tests and choose which test, one of the tests from the list of tests, and click edit. And you can see all the information about the reagent, about this parameter. You see the name of parameter, the alias ID. This is very important. If you connect the analyzer Maglumi with the alias, the name of the parameter for you need to input in the alias software should be the same name that we have in the user software. in the user software of Maglumi. So if you write it HCG, you have to write it HCG here. If you write it beta HCG, it is beta HCG. If you write it, for example, HIV 1, you keep space and then you write 1. You need to write it in the same way here. If you don't make space, for example, like this, you need to write it in the same way here. Otherwise, there will be no recognition of the parameters. So when the alias send the order for the parameter, it will not be executed, recognized by the user software. And when the user software sends the results, the alias will not receive, will not recognize this parameter. So this is very important to have the same name for parameters in the user software and in the list software. Next is the unit. You have the unit for this parameter. You can change the unit, but remember, this is very, very important. If you change the unit, you need to change the normal range and the measuring range for the parameter. You need to change the normal range for the QC. You need to change the target value for the QC. This is very important. So if, for example, the customer change the unit, but don't change this, it will call you for sure to tell you that all my results are not okay for the samples and for the quality controls. So pay attention. Next is the calibration. We have the replicate for the calibration, 2 times for low, calibrator low, 2 times for calibrator high, calibration validity period displayed here. And we have the normal range and the measuring range. And on the bottom, we have the extend calibration calculation. So for what means extend calculation? This is the measuring range. I told you this is the curve for this parameter. For example, the normal range is from 0 to 10. The measuring range, the upper band is 5,000, which means that after 5,000, the results will not be displayed. This area will not be displayed. The results in the right side of 5,000 will not be displayed. If you want to display the results after the upper band, you can extend it. For example, put here 6,000. And then the results will be displayed from 5,000 to 6,000 will be also displayed. So this will be the new measuring range. But we don't suggest to use it because after the upper band, the results, the curve will not be so accurate. Then we have the share calibration data. Also, this is very important. You see here the calibration stability is 28 days, means after calibration of the HCG, 28 days later, you need to recalibrate again the parameter because the calibration will expire. Share calibration data means that when we load a new calibration kit, we can use the old calibration kit. Old calibration means that, for example, each reagent kit from Snipe has calibrators. That means that normally each time we load the reagent kit, we need to calibrate. This is why we provide calibrator in each kit. So each kit should be calibrated separately. So, but if the customer, for example, use the HCG, the calibration stability is 28 days. If the customer finish this reagent kit after 7 days, so 21 days before calibration, that means the consumption is very high in the lab. So the user can load another reagent kit, HCG, without making calibration, without calibrating the new kit, just by sharing the calibration of the previous kit. The condition is that the lot number should be the same. The lot number should be the same between the previous reagent kit and the new reagent kit. If we load the new lot number, for sure we need to calibrate. But if we load the same lot number, we can share the calibration data. So we don't need to calibrate the second kit, and we can save the reagent. So this is for the lot number, and if we are sure that the customer can finish the second kit before expiration date. For example, if he finished the reagent kit after 20 days, so still remaining 8 days from the expiration. So in this situation, we cannot suggest to share the calibration data because he finished the reagent kit, the previous one, after 20 days. So we cannot be sure that he can finish the next kit in 8 days. On the bottom, we have the diluent. So this is to make those reagents without diluent in the 7th vial. We said that in the 7th vial, we have diluent, and not all the reagent kit have the diluent. So some of them doesn't have the diluent, which means that we will not find them in the definition interface diluter when we add the dilution ratio because they don't have diluent. So if we select this parameter, for example, this parameter doesn't have diluent. If we select here, we make this reagent kit without diluent can set the dilution ratio in the dilution definition interface. So after we click this, we choose this, the parameter will be displayed in the interface, in the definition diluter interface. In definition, diluter will not be displayed. Previously, it will not be displayed here because it doesn't have diluent in the 7th vial. If we click like this, it will be displayed in the list here, and we can create dilution ratio for this for the parameter. Then on the right side, we have some other button: auto dilution, format, custom mark, reflex 1, reflex 2, and QC rules. Here we can see one by one. And of course, we have the master curve here. So we can check the master curve for each parameter. The master curve for reagent from Snipe have 10 points. For each parameter, the master curve has 10 points. You can see the 10 points, 10 RLU and 10 concentration. And this is the curve for each parameter. So we don't suggest to change the RLU and concentration because it will affect the accuracy of the results. Then on the right side, we have the auto dilution. The auto dilution, we can set the auto dilution for each parameter. So the auto dilution, the dilution will be run automatically at the end of the test. So when the results of the test is out of the measuring range, so this is the measuring range, for example. This is the measuring range. If the results is higher than the upper band of the measuring range, the dilution will be run automatically. But you remember, the auto dilution need to define the dilution ratio. So which dilution ratio will be used for the automatic dilution? So we said in the definition, we can set up to 9 dilution ratio. Which one will be selected? From here, we can select it, the auto dilution. So select the auto dilution ratio. So how to select the auto dilution? We need to know the upper band of the measuring range. For each parameter, we have the measuring range from starting value to the lower band to the upper band. For example, for HCG here, it is from 0.3 to 5,000. So what we do is to make the threshold. The threshold is the upper band -1. the upper band minus 1. It is 5,000 minus 1, which means 4,999. And then we set the dilution ratio by setting the sample volume, the diluent volume, and then we click OK. So how to set this process? So definition test. For example, this parameter, for this parameter, the upper band is 20,000. So we will set the threshold for the dilution 3,000. So here we don't have the this dilution for this parameter. So it is 20,000 minus 1, which means it is 19,999. I don't have parameters in my. Okay, so this parameter is 24 for the upper band. So the threshold is 23, 24 minus 1. Okay, so now I will input the threshold 24 minus 1, which is 23. Sorry, 23. And then I want to use, I choose my dilution ratio. Maybe I will put 1 to 4, for example. And then click OK. And the dilution ratio for this parameter will be each time the analyzer will run the pair A in the analyzer, and then the value is higher than the measuring range. It will dilute automatically using the dilution ratio 1 to 4. So this is not the dilution that we do manually. This is automatic. No need to intervention of the user. And then on the bottom, you can see we can select here, click start to generate schedule. So here, if you select it, if the result exceeds the upper band, user need to click start button to complete the auto dilution. It is alarming you. It is allowing you to choose whether you want to run the automatic dilution or not. So it asks you for confirmation. But if you don't select this, the analyzer will automatically run the dilution ratio without asking, without displaying any message. Next is the format. It is just to choose the number of decimal to display after the dot, the number of digit to display after the dot. So when we have lower concentration, lower value, lower results, we need to display the maximum number after the dot because it is very important. So 0, 0, 1, and 0, 19, for example, and 0 comparison, for example, between 0,195 and 0,2 is very important. So the difference, if we don't display this difference, it will be displayed 0.2. Here is 0.2, and here also is 0.2. So we cannot compare. So we need to display the maximum digit after the dot. But when we have high value, 10,000, we don't need to have 10,000 minus 101, for example. It doesn't have meaning because the value is not important behind this big value. Then we have the custom mark. So we can add some marks. For example, we can set, for example, the range or the threshold value, threshold value 1, which means the value is higher than this threshold value. It means the analyzer will display, for example, positive, and lower than this value, it display negative. This is just some marks. Then analyzer, it will display these marks in the results at the end. For example, normal. for example, very high, extremely high, or extremely low, or maybe some labels like this one, some symbols, lower or higher. Then we have the reflex. Reflex 1 and reflex 2. What is the meaning of the reflex? The meaning of the reflex that if we add the interval, reflex interval, and then select, click reflex and select some parameter, that means that if for this parameter the result is inside the reflex range, then we need to run another parameter. Then automatically we will run another parameter. For example, this is TSH, for example. Then you can choose for TSH range, for example, 1. If the result is between 5 and 10, for example, we click reflex and we select the T4, and the analyzer will run the T4. If the results of TSH is between 5 to 10. 44. So the analyzer will automatically run the T4 for the samples, those samples having the result of TSH between 5 and 10 will run automatically T4. We can add another reflex range up to 2 reflex range, and we can put here if the result is between 10 and 15. For example, if the result for TSH is between 10 and 15, it will run automatically the reverse T3, for example. Automatically will be run. So this is to avoid that the doctor know that there is a relationship between the main parameter and the reflex parameter, and he know that if he get the results between 5 and 10, and the patient will take these results to his doctor, and the doctor will ask him to go back to run go back to the lab to run again, to test again for T4. So using the reflex tests, we can reduce the time for the diagnostic. So instead of going to the doctor and back to the lab again to run other tests, we can do it during the first time, because we are sure that the doctor will ask for these tests. Then we have the QC rules, some WistGuard rules that the customer can choose freely as required. Then the next functional button is the control. We said here we can add and modify controls, you remember? So add the controls, add all the information, the name, the lot number, the range, and the target value, and the SD value. And then we have the group. The group, if we click group, all the parameters will be displayed here. And then we can make a group of this parameter and give a name. Thyroid panel, for example, cardiac panel, any panel. And then we select the parameters for this group, and then we click save. And then later, this parameter will be displayed in the first page in the interface sample and reagent. You see in the first page, because here we have a different page. If we do this group, when we are in the sample and reagent, the parameters will be displayed in the first page. We don't need, so we can choose the parameters in the group. We can choose the parameters that are commonly used by the customer during the routine. They are the most used, for example, for TSH, for example, and T4, T3, and HCG, for example, and so on, FSH. We can display them here. The other parameter we run rarely will be displayed in the next page. So this makes the selection of the parameter very quick. And Next is the profile. Profile is similar. It is also a group. So we click profile, we select, we give a name for our profile, we select the parameters, and then click save. And then this parameters, this profile will be displayed on the bottom in the sample and reagent area on the bottom. But here the difference is when we click it, all the parameters included in the profile will be selected for the sample. So we can select the thyroid panel, for example, fertility panel, and so on very quickly by just clicking one button. Next is the diluter. I told you it is to select the dilution ratio for make a list of dilution ratio for each parameters. Select from the existing list on the top or click edit to add your own dilution ratio. Next is the result definition. So here also is some functions and options that can be used by the user if needed. So for example, results not shown while pipette or error exist. So here it will not show the results. It will display error instead of the results. So no concentration will display error. For example, results automatically validated. Results not transmit to list system while pipette or error exists, and so on. So click the option you want to use and click save. Next is the system interface. The system interface. In the system interface, firstly, we have information. In the information, you have the serial number of the analyzer, the serial number, the version of the software, and the version of the firmware. You can, for example, check after making the software upgrade, enter the system information and check whether the upgrade is done successfully. For example, this is your version 2.14.18.1, and now you have the new version, for example, 2.14.19.0. When you make the update of this one, you can, after the update finish, enter the system information and check whether the version is changed to the new one. Same thing for the firmware. Then we have the setting. In the setting, we have mode, online, user management, language, and audio alert. For the mode, we have the random mode and the batch mode. We can select random or batch. The difference is that for the random mode, load samples at any time. The first sample loaded will be the first sample pipetted. And the batch mode is different, very different. It is using the reagent. It is running based on the parameters, not on the samples. The first one is based on the samples. So the first one, this is the sample area. This is the sample rack, and these are the tubes in the sample rack. And this is the second sample rack, and so on. So when we use the random mode, means the analyzer will run the first tube, the tube number one, all the parameters of the tube number one, then move to the second tube, run all the parameters for the second tube, and then to the third, and then finish the first rack and go to the second rack and do the same thing. But when we choose the batch mode, it will be different. For example, first sample, we have TSH, LH, estradiol, and for the second one, we have also TSH, HCG, and maybe LH. And the third, we have HCG, and estradiol. FSH for the fourth. So if we use the random mode, the analyzer will start by the first tube, run the TSH for the first one, the LH and the estradiol, all the parameter for the first tube. Then move to the second tube, run the TSH, HCG, and LH for the second tube, and so on. If we run using the batch mode, it is based on the samples. But here it is based on the assay parameter. So in the batch mode, it will, for example, start the TSH. It will run the TSH for the first parameter and then move to the other parameters looking for TSH. So it will run the TSH for the first parameter. It will run the TSH for the first parameter, then go to the second for the first tube, then the second tube. It will run TSH for the second tube, then check the TSH for all the other tubes in the sample area. After that, so only TSH. After finishing the TSH, you will move to LH for the first parameter, for the first tube, sorry. Then check the LH for the second, run the LH for the second tube. Then check in the third tube and the tube number 4 and so on until it finish running all the LH. Then move to the estradiol. Run the estradiol for the first tube. Then no estradiol for the second tube. Then it will run the estradiol for the third tube and then move to the other tubes and run all the estradiols. And then come back to the other parameters and do the same thing. So this is the difference. When using the first, the random mode, we will lose some cuvette. Because why? Because if, for example, we run the TSH and the TSH need 15 minutes incubation time. So the incubation time is different between different parameters. So if the TSH has 15 time for the incubation, we will put the cuvette in the incubator and we will use one cup for TSH and the other. If LH has the same time, incubation time, it will be run with the TSH. But if LH has, for example, different calibration time, incubation time, it will not be run with this one. So it will use another cuvette for LH. So we will consume more cuvette using the random mode. So this is for LH. For example, estradiol has the same incubation, so the estradiol will be run with the LH, but the TSH will use its own cuvette. So this is but when we use the batch mode, all the parameter, we will start by one parameter. So the parameter, they will be run together in the same cuvette. So we will save the cuvette. We will save and reduce the consumption of the cuvette. So we know that, for example, TSH, we start by TSH. All TSH will be run with the same cuvette. And then the second parameter also, all the tests will be run in the same cuvette. So we will save the consumption of the cuvette. Next is the edit sample mode. So this is to edit sample mode. We have different mode. The first mode is the normal mode. In the normal mode, the barcode reader read directly the ID of the sample from the barcode label on the tube. The quick mode, the software directly generates the sample ID automatically. The online mode, it is from the alias. So it is sent by the alias. For the emergency mode, when there is an error, so when you connect the your software, your Maglumi to the list, you have to select this mode. So it is used for the list mode, the online mode. And for the emergency mode, the last one, the emergency mode, it should be selected in case you have any problem with the sensor of the sample area or the reagent area door, or you have a problem with the barcode reader. So if the sensor of the sample area and reagent area door is damaged, for example, and if you have the barcode reader damaged, for example, not working, you cannot use the manual input of the sample ID. Instead, you click emergency. So when you click emergency system, because if the barcode reader is not working, when you load the sample area, the sample rack in the sample area, it will display, instead of displaying the rack, it will display error like this. Because the barcode is not working, you will get like this error. And in this situation, the rack is not displayed at all. So you cannot edit manually the samples ID. But if you choose emergency mode, it will display a rack like this. And then you can click manually and enter manually the sample ID. You can see here, if the barcode is not working, if the barcode reader is not working, you will get this situation. So you cannot enter, you cannot select the rack and enter by yourself the ID. But if you select the emergency, it will display the rack. And then you click the rack and you enter manually until the engineer arrives to fix the problem. So you can continue using the analyzer by editing manually the sample ID. Next is the online. It is just to select the protocol for the list connection, the IP address and the baud rate, the protocol, and so on. So this is for the person who connect the list for your Maglumi. And on the bottom, you can see the communication status. When green, that means the connection with the list system is with the list software is established, is okay. When it is red, means it's not connected to the list software. Next is the user management. You can add more users. You can add a user. You just need to click user management, enter the username, the password, and select whether the user is normal user or super user. What is the difference? The difference is that the normal user has less right than the super user. So the super user can do other things that the normal user cannot do. For example, delete the results. This cannot be done by the normal user. Change the master curve, modify the concentration and the RLU of the master curve. Change the calibration results or reedit the journal results. This is only done by the super user. But we don't recommend to do these actions. Then we have the language. We can choose the language according to the area. Then we have the maintenance. We have seen this in the SOP, the daily maintenance, the user maintenance, the weekly maintenance, monthly maintenance. Then we have also another maintenance button here. From here also you can run the prime all, and you can run the tubing cleaning solution, the wash pipe. We said the tubing cleaning solution, you can run it from the monthly maintenance. Load the tubing cleaning solution and then click run to run it from here. But you can also run it from this interface. You can do the prime for pipette or washer and chamber from here. And you can also run the tubing cleaning maintenance. 13 milliliter of tubing cleaning solution in the vial number 5 6, and 7 and load it in the reagent area and enter here, tubing cleaning solution, click start wash and click confirm, OK to confirm. Next is the statistic, the last one in the system. Statistic is to, when you click statistic, click reagent consumption. You use it to check the consumption of all reagent during a certain period. So choose the starting period, starting day, the ending day, and click search, and you will have the statistics of consumption of all the reagent during this period. Next is the results interface. For the results interface, we have journal. In the journal, so firstly on the top, you can see we have the period. You can choose the period where the results are situated. You want to search from a date to another date. You can choose following according to parameter, write a parameter. You can click today's results, so you will only display today's results. You can click the criterion, the sort, to change the criterion of the search according to your need. Like, for example, chronological, for example. And then on the left side, you have different buttons. The journal, it contains the results, all the results, except the results that are validated. You remember, we said here we have the sample result, for example. After validating the result, they go to the valid result. In the journal also, we have the QC results. After validating the QC results, they go to the QC results interface. So it contains all the results except the validated result. The valid results contain the validated results for samples, only samples. Calibration results contain the validated results for calibration, only calibration. And the QC results contain the validated calibration quality control results, only quality control. System tests contain the results of the system test, and the QC quality control report. And the report, the last one, is the sample report. So in the user interface, in the results interface, you can see it displays the sample ID, the assay parameter, the dilution, if available, the RLU, the CV, the concentration, and the flight. And we have seen the meaning of this flight. This is very important. And then on the bottom, we have some functions. So when you select results, you click here to select it. If you want to recalculate, you click recalculate. If you click recalculate, it will recalculate the results, selected results with new calibration curve. I told you when you calibrate, you can share, you can use the calculate associated results for the same day. If you click results, select results, and click online, it will send the selected results to the list software. If you select results and click valid, it will validate the results. And then if it is sample, it will go to valid results. If it is QC results, it will go to QC results. And then if you select results and click print, it will print the results. If you select any results and click remeasure, it will redo the test from the beginning. So you don't need to order it again. But here you have to make sure that you still have your samples loaded in the analyzer. You want to redo the test. So you need to make sure that your sample tube is still on board the analyzer. And also the reagent kit is still on board the analyzer. And they should be in the same position. For the sample tube is still in the same position. And the reagent kit is also still in the same position. Next is check and edit the QC results for the QC interface. So you can go under batch QC, and then you will see the display of the QC in this format. Lot number, QC name, lot number, target value, target SD, and the mean value, and so on. You can also click QC graph to check the results, the variation, the fluctuation of the results during every day. For the batch QC, so here you have the batch QC and you have also the monthly QC. For the batch QC, total of 30 results could be shown on the graph. Every day one QC. For the monthly, for the monthly QC, sorry, it is every day one QC. Even if you do run two QC in the same day, it will take the last one. So total of 31 results could be shown on the monthly. And if the customer ran QC for many times on the same day, only the latest QC results will be shown in the QC graph. How to print the QC report? Click print QC, select print setting, and then select the report and analysis, and then click print to print it. For the results report, you can enter the results interface and the report, and then see the different function in the report. So for the import information, it is to import the sample information. Search the historical test report. QC is to return to the QC interface. And dictionary manager, set the report information. And print setting is to set the format of the report sheet, report paper. And the return is to return to the journal. So how to preview and print the report? Method 1 is to enter search, and then enter the criterion. You want to enter some information to make your search more precise. So maybe the patient number, maybe the department, maybe the doctor who sent the patient, maybe a period between one day and another day, and then click search, and then it will be displayed according to the criterion. You will get the result of the search, and then click preview to preview before printing, to check the report before printing, check the information. If everything is okay, you can confirm the print by clicking print. The second method is to click import. Click import, and then modify the informations here, and then click get the results of the search, and then select the results, the report you want, and click print, and then confirm the printing by clicking the print target, and then click OK to print it. How to set the report information in the dictionary manager? You can select the information you want to display in the patient report. So department name, doctor name, sample type, sample status, and so on, reference range. So you can select one of them and then click add, and then add another one, and so on, and at the end click save. For the assay define, you can, for example, specify the method, the assay method. For example, if it's CLIA, you can add. So in your report, you will display the assay method, or maybe also the analyzer, Magnumi CLIA. And then it will be displayed in the patient report near the result, near the parameter. You can also add the multiple reference range according to the male and female and the age. Select the reference range, so results, report, and then dictionary manager, reference range, and then select the parameter, and then you can add different range, lower band, upper band, and also the remark if you want. Also select female or male, or maybe children. You can select the sex, of course, and then multiple range will be displayed in the report. That's all for this presentation about the user software. Do you have any questions? Okay, the last point is just 5 minutes, and it is the consumable calculator. It is a small tool. It is an Excel table that help you to know the consumables, the amount of consumables needed for any customer during a certain period according to his throughput. So firstly, in order to not forget, I will share with you the link for the training. So the questionnaire, you can give your idea about the training, or you can give your suggestion for the training. You copy it in your computer or your phone number, a cell phone, and then if you just click it or copy it and paste it in your internet browser. And then it will open. It is write your country, of course, Russia, company, name and date, and then it will take just 2 minutes of your time. Then select your answer here, and then at the end you can give your suggestion if you need, if you require any other training, any other topics, and after that you click here to send the feedback. It is in Chinese. Just click, and then another page will appear. It's just advertisement, so forget it. So it's just 2 minutes. So please, if you have time, you can fill it after the end of the training. So for the consumables calculator, it is done by Snipe for according to the real consumption in the practice. So here in this table, you have the test per day for the customer. It is divided into 2 types of tests. We have one-step assay procedure, one-step assay procedure, and two-step assay procedure. So the consumption is not the same because if you remember, I told you for the one-step assay, the cuvette will be sent to the pipetting position. It will add, so pipetting position, and add reagent and sample. Then it will go to the incubate, and then go to the washer for washing, and then to the chamber for measurement, chamber for measurement. This is one-step assay, one step. For two-step assay, the cuvette will be sent to the pipetting position for pipetting. First pipetting, and then sent to the incubator. Incubate. First incubation also, and then sent to the washer for washing. 3 cycle of washing like this, 3 cycle. Here also 3 cycle, but the first washing. After that, it will not be sent to the chamber. It will be sent back to the pipetting position again in the back transport. So it will pipette for the second time. And then after the pipetting, it will be incubated for the second time. So second incubation. And then it will be sent to the washer. So it will be washed 3 other cycle, 3 more cycle. It is the second washing. And then it will be sent to the chamber for the measurement. So we have, especially for the washer, 3 cycle here and 3 cycle here, which means 2 times, double than one-step assay, which means it consumes more wash liquid. So the consumption will not be the same. So this is why we differentiate them. So the 2-step assay, there is some few parameter using 3-step assay, and the consumption is quite similar to the 2-step assay. This is why we make them together, but they are different from the 1-step assay. So you need to estimate approximately the number, the amount of tests per day for the customer and divide them to 1-step assay and 2 3-step assay. And then choose the period. You need to know the amount of the consumables needed for 1 month, for 2 months, for 1 year, and so on. So you can choose the time, the duration. And then here you have the price also. You can enter the price. So firstly, for the for the consumables, the amount of consumables, just enter the amount of tests. For example, this is 100 tests. 25 belongs to the 2-step and 3-step assay. 75 belongs to the 1-step assay. I need to know the consumables needed for this customer that having 100 tests per day during 6 months. So it is 27 starters, kit of starter, 35 kit of wash concentrate, 14 kit of cuvette, 2 kits of life check, 1 kit of tubing cleaning solution. If I change here to 3 months, for example, the value will be changed, the amount of consumables kits will change. If I change, for example, in the tests, for example, I will put here 100 tests, the value will change also. And another thing, so first thing is to provide you the suggested package for this customer. But the second thing is to give you the total cost per test of the consumable per test for each consumables, and then the mean cost. So the average value. So here you can enter the price, your local price for all the 5 consumables, and then you will get the total cost per test. So in this calculator, you just need to introduce the value in the green color. You can see, please kindly input the test per day and price of consumables in the green part. So just modify this part. The other parts don't touch. So here you can get according to the price you enter here, and according to the throughput, you can get the suggested package for this customer, and also the total cost per test for the customer. For example, you change the price of the cuvette. You put 100, and it changes the total cost per test. Is it clear, my friends? Any question? No, you don't need to add the consumables. You have all the consumables here. You have all the consumables. And it is making the estimation from the study in practice, how the starter, for example, is used. The starter is used for the priming, for the system test, and it is used for the tests each time the cuvette arrives in the chamber. At the end of the test process, the starter will be the starter injector will inject 200 microliter. So this is an example. but the different model. This is for M series. This is not for X series. This is for M series, and for M series, of course, the consumable is the same. The consumption may differ a little bit because if you have, for example, 2 pipettos, then the priming need to be done for 2 pipettos. There is a little difference, but it is still consume the starter in the same way and consume the cuvette in the same way, the same number of cuvette. It depends on the test because it depends on the test. So the difference is very, very small between the models of the M series. And for the X series, it's different because the cuvette are completely different. Yeah, you are right. For example, the starters and the wash liquid and the cuvette, they depend on the throughput. But for example, the light check and the tubing solution, they don't depend on the light check. They don't depend on the throughput. They just depend on the time, because independently of the throughput, the analyzer will consume the same amount. For the tubing cleaning solution, we said it is monthly maintenance. So each month it will consume 39 milliliter. And the bottle of tubing cleaning solution has 500 milliliter. Then if it's Maglumi 800, because we said we put in the vial number 7, 6, and 5, 13 milliliter in each vial. So the total is 39. And for Maglumi 800, it will be used for 1 year. Because 39 per month, which means 390 milliliter per 10 month, per 10 maintenance. So during 12 months, we can use 500 milliliter, can provide us 12 maintenance, which means 1 year. And only, but if it is, for example, 4,000 or 2,000, they have 2 pipettos, so we will use two. It will consume more than 39. It will give us 6 maintenance, which means 6 months. For 800, it is 1 year. So it will stay here, even we change the throughput, it will stay here until we exceed 1 year. For example, 400 days. Then 400 days, it will change to 2 because the second year. This is for 1 pipettor. For 2 pipettor, it's 6 months. And it's just estimation, but it is close to the reality. Any other question? Okay. Okay, so later, after I will have a lunch, and then I will send you the presentation about the quality control. You are welcome, my friend. So for those who shared with me their email, I will send the presentation of the quality control. You will get many informations how to get the results information from the website and so on. And it is true not only for Snipe, but for all the other brands, because Roche and Siemens and so on, they use also third-party quality control. Okay, my friends, so Thanks a lot for attending this training. If you remember to copy the link for the feedback, for the training feedback. If you have any question, feel free to ask. Okay, I will send you, Irina. Okay, so my friends, if you have other questions, you can ask me now. If you don't have question, then see you next time. I hope we can meet next time. Okay. 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 So have a nice day, my friends. Take care and have a nice day. Bye bye. See you.
Recording stopped.